Okay, atmospheric science students, welcome back. I am just over here on my computer. I'm logged into Chesapeake, and I am going to do a little bit of programming here to show you some examples of working with functions. So let me go ahead. I'm just going to make this, let's just call it functions.c. That sounds lovely. And I'm going to do my usual pound include stuff up here. Pound include math.h, pound include stdio.h. And I'm going to write my main function here. What do we want this program to do? How about we convert acres to square meters? Okay, this is not what you're doing exactly in your problem in the homework, but it is an example of the kinds of things you could be doing. So like, for example, I would say something like, how many acres do you farm? And we would then use a scanf statement to read in a floating point number that we'll call acres. All right, well, we don't have that, so we better go over here and declare it. Float acres. All right, now, let's say we wanted to convert that to square meters. I'm going to call that, let's just say square meters will be the name of my variable. I better declare that. Float acres, float square meters. Oops, square meters. Now, square meters is equal to a very small, to a very specific conversion from acres. Let's actually make a function that can do it. Let's call it acres to square meters. I'll call it acres to meters squared, like that. Okay, underscores I think are okay in C. We'll have to find out. And I'm going to pass it a value of acres, and we'll see exactly how this is going to end up working. But over here, my main function, then I'm going to say printf, did you know that is %f square meters /n. All right, doesn't that seem like a goofy little program there, right? We're going to just prompt the user for how many acres that is, and we're going to use a new function that we're going to call acres to square meters. And that function is going to take as input acres, which is a variable that stores the number of acres in a floating point format, and it's going to convert it to square meters. All right, so now, as I said before, there's a couple of different ways you can place where the functions can be, but one of the things we can do here is we can put them between the pound includes and the main. And I'm going to say that this is a floating point function called acres to meters squared. Acres to meters squared, and it's expecting as input a floating point number. Now, just to make sure that we're exactly clear as what's going on, I'm going to give this floating point number a different name. How about A? Okay, we did not use A in the main program. I want you to understand, when I invoke this function, acres to meters squared acres, this value, the actual number that's in here, is going to go up and get put into this value right here. This is the first argument of our function, and it's going to go into the first argument here. All right, so like for example, up here in our main function, in our floating point function, acres to meters squared. Excuse me. Let's say I'm going to make a function variable called m2 for meters squared. Meters squared is equal to a times, and there's a conversion which I happen to have just looked, 4,047. Let's just say is close enough. 4,047 meters. Close enough. So A will get multiplied by 4,047, and then we'll just return the value M2 to the main program. So whatever that number is in M2, all of this is going to get replaced by that. So now that number gets put in here. Square meters is equal to that. And, oops, I didn't finish this here. Then here, this is going to be equal to square meters. There. Did you know that that is %f square meters? Square meters will get put into this %f, right? All right, let's test this program and see if I've made any mistakes. GCC functions.c minus lm. Oh, it compiled, so there wasn't any syntax errors anyway. Doesn't mean the program necessarily works, but we'll find out. We'll launch the program using the a.out command. How many acres do you farm? 100 acres. Did you know that is 404,700 square meters? All right, well, that seems to be okay as to how that works. I don't like that ugliness as to how it's printing. It bothers me so much that I think I will actually change this to, let's try let's just say 1 digit or something like that. That'll be fine. Okay, now, again, let me just show you. If I recompile this using bang-g, or we could have typed gcc functions.c minus lm. We could compile it. How many acres do you farm? 100 acres. Did you know that that is 404,700 acres? 407,000 square meters? Lovely. Okay. What's nice here is that we could reuse this code. Like, for example, then I could say something like printf, a square mile is, now let's not do it that way. Let's say 1 acre is percent 0.1 f square meters. And I could do something like put acres to meters squared of 1. I just want to demonstrate here that there's another way we could use the function, right? We could just literally send a value, 1, into acres to square meters, and then that'll go off to this function. A will be equal to 1. We'll get a value back of 4,047, which will then get printed in 0.1f format. Let's see how that works. Compile it. Run it. How many acres do you farm? 100 acres. Did you know that is 404,700 square meters? 1 acre is 4,047 square meters. All right. Let's try a few other things here. I just want to demonstrate that certain things aren't going to work. This is called the scope of these variables. Scope tells us where the variable has meaning. For example, see how in here, in our acres to meters squared function, we have a floating point variable called a. And we do things with a, like multiply it by 4,047 and so on. It seems like, okay, we should be able to then go over here and say printf, the value of a is percent f. Doesn't that seem like that should work? I mean, we have a variable called a, and I should be able to print that value of a in percent f, and it should work, right? But it won't. Watch what happens. If I try to compile it, error. A is undeclared, first use in this function. In other words, from the point of view of our main function here, first use of this function. In this function here, we never actually said float A. A has no meaning over here. On the other hand, if I had done that same line right here, let's just say I printf the value of A is percent f slash n, just to try it. Now see, inside this function here, float acres to meters squared, A has a meaning. We've declared it. We're using it. A value gets passed into it. If I recompile, it compiled just fine. How many acres do you farm? 100. Oh, look, actually gives us more. Let me clear this out and show that to you again. How many acres do you farm? 100. The value of A is 100. Do you know that that is 404,700 square meters? And then when we called that function again, when we invoked that function again, A was equal to 1, and we got 1 acre is that many square meters. So see how the scope then tells us that A only has meaning inside of this function. And in the same way, variables that we used outside over here inside of our main function have no meaning inside of float acres to meters squared. For example, inside of our main function, we had a variable called square meters. Okay? If I tried to printf the value of square meters is percent f slash n square meters, this isn't going to work either, because square meters was never declared inside of acres to meters squared. So if I try to compile this, again, I'm going to clear the screen just to make this more clear. If I try to compile this, we'll get an error. In function acres to meters squared, error, square meters undeclared, first use of this function. Yeah, because inside of acres to, it's like its own little separate universe in here. The variables like square meters that exist over in main are outside of the scope of the universe that is the float acres to meters squared function. They don't see each other. In fact, that's a very useful thing, because here's the deal. think again about that function sine that's hanging out someplace in the math.h libraries or whatever. It probably takes a lot of calculations to compute the sine of a number. I kind of know how it's done, but it's got to be a lot of math. There's probably a lot of variables involved in that. I don't even want to know what those are called, and I don't want to know anything about what's in them or anything like that. I just want to know what my sine of my number is. I don't want to know anything about it, and I don't want to... let me show you something else, actually. Let's reuse a function, a variable, printf. Inside the function, a equals %f. All right? Now, what if I made another variable here inside of the main function called a? Can I do that? Absolutely. They're like two separate little universes here. All right? So like I could do something like a is equal to 3.14159. Here, let's add a line here that says, hey, where are we? There we are. Printf. In main, a is %f/na. Heavens, we can even do it down here. We can do it down here. I'm just using the cut and paste function to put it a couple places. If I compile this function, I'm going to clear out the screen so you can see what happens. Notice, in main, a is equal to 3.1459. How many acres do you farm? Well, inside the function, a is equal to 100. Do you know that's equal to this many square meters? Inside the function, now a is equal to 1. And 1 acre is equal to this. In main, a is equal to 3.14159. Notice they're like two little separate universes there. The a that is inside of acres to meters squared has nothing to do with the a that exists out here inside of main. These are two different values, two different variables called a. Fortunately, we won't do that on purpose very much, but it will happen probably by accident. Where, like, for example, you'll have a function that computes the vapor pressure, and then you'll have a function that like maybe you'll have a variable called vapor pressure or something like that, or you'll have a function that computes something like relative humidity, and inside of that function there'll be a variable called vapor pressure, because relative humidity is vapor pressure divided by saturation vapor pressure. It'll probably happen by accident, but we aren't going to deliver. A computer science class would try to trick you and have programs that have all this kind of tangles of variables with tricky scopes. Where is that? Is a valid inside of this function or outside of the function? Is it inside the scope of this function, and is it inside the scope of the other function? We're going to avoid that if at all possible, because that's just trickiness. There is a way to make a variable that goes anywhere. It would work inside the functions, and it would work outside the functions, and so on. But we're not going to do that right now. That is called a global variable, and that's in many ways a bad technique. So we're going to avoid that if at all possible this semester. Okay, I've got a couple more slides I want to show you on the PowerPoint. So I'm going to let you go and just wait through this little transition to get to the second part of this lecture, or third part of the lecture, or whatever.